Good evening to one and all. Today we are discussing about the quicksort algorithm. Quicksort. Quicksort is an efficient sorting algorithm that works by selecting the pivot element from an array and rearranging the other elements so that smaller the pivot element comes before it and those larger come after it. This process is repeated for the subarrays on either side of the pivot until the entire array is sorted. It is known for being fast and requiring less memory since it sorts the array in place, but in worst case it can slower if the pivot is poor. Despite this, commonly used for large data sets due to its average time complexity is order of n log n. Key concepts: quicksort follows the divide and conquer. The algorithm splits the array into small subarrays and sorts those subarrays and then combines the result. It uses the pivot element. Quicksort uses a pivot element to partition the array into smaller subarrays on where all elements are smaller than the pivot and one where all the elements are greater. The pivot is placed in its correct position and the process is repeated for the two subarrays. Steps for implementing the quicksort. First we have to choose a pivot element from the array. This can be done in various ways such as selecting the first element or last element or random element or any element present in the array. Next step is partitioning the array. In quicksort, we partition the array into two subarrays, one with the element smaller than the pivot and one with the element greater than the pivot. Third step is we recursively apply the quicksort to sort the two subarrays until each element is singly sorted. Then the final step is we combine the subarrays and then sorted the final array. Pros of the quicksort. Quicksort is very efficient for large data sets. In place of sorting, which means it does not require any additional memory like the merge sort. In merge sort, we uses the temporary memories to store the temporarily sorted arrays, but in quicksort we do not use, so this can enhance the memory performance in computers. Quicksort often faster in practice than the other algorithms like merge sort, despite having the same average time complexity of order of n log n. Cons of the quicksort: it is not stable. Equal elements might not retain their relative order. It is not stable when compared to the merge sort. Just look at about the pseudocode to understand the quicksort. We have a function called quicksort. In this we taking inputs array low and high. We checking the condition. If low is less than high, pivot index is equal to partitioning, and we call the quicksort quicksort again to pass the array low and pivot index -1. In next step we pass the array pivot element and higher index to divide the two arrays. In the other step we use the function name called partition. In this we taken the parameters array low and high. We check if the pivot is equal to array of high, then we in place of high we use low is equal to low -1. For using for loops we check if the array of j is less than or equal to pivot, then we increment the value of I. Then we use the swap to swap the values of I and j, and with us we are returning the I plus 1 value. Let us look how the quicksort performance. We have these elements 14, 12, 16, 13, 11 and 15. We selected the 14 element as a pivot element. In this pivot element we divided the array. The elements which are less than 14 are placed left side and the elements greater than 14 are placed on the right side. In this left side we take the pivot element as 12 and this step also we put the 11 on the left side and the 13 which is greater than pivot on the right side. In this right array we take 16 as a pivot element and the elements less than placed in the left side and the elements greater than right side. Thus in the final step we can achieve the sorted elements. Thank you.